Hey y'all, I'm David, and this is Lab 3 over circuits. So for our introduction, the purpose of this lab, we wanted to use the energy and charge conservation principles to predict the behavior of circuits both in series and parallel, and then use multimeters to measure the values of conventional currents as well as potential differences in the circuits. And finally, we wanted to examine the behavior of resistors and capacitors. So for a quick preview, delta V came out to be 0, and the current came out to be zero point zero 0.02 amps. Increasing resistance increased the charging and discharging times. So the fundamental principles for this lab are Kirchhoff's voltage and currents law, current laws, Ohm's law, and the RC equation, which are modeled here. So as you can see, the summation of the potential will be 0 within the loop. And then this allows us to linearize our RC in order to find our actual resistance constant. And then for the DC circuit experiment, the predicted current was zero point zero 0.02 amps and the voltage was 3. Uh, and our measured current came out to be zero point zero 0.02. And when we reversed the ammeter, it was still zero point zero 0.02. Attaching the voltmeter read -3, and when the voltmeter was attached, the ammeter read 0. So here we can see we began at 3 volts, and then when there was no resistor present, there was no change in potential. But once we introduced a resistor, the potential difference dropped, and it dropped more based on how much resistance there was. And the calculated resistance of our 47 ohm resistor came out to be 48, and for our 100 ohm resistor came out to be 102, um, which these values are just slightly off due to rounding in the math. So for the RC circuit experiment, uh, what I observed was that the bulb began bright and it slowly dimmed as the capacitor charged. And then when the capacitor discharged, the bulb became bright again and it dimmed slightly quicker than when the capacitor was charging, which we can see in the charge and discharge times for both the 10 and 20 ohm bulbs. And then here are the values for the RC for both of those. Okay, and here is a graph of time versus our linearization of the voltage. And as you can see, our slope is negative 0.1668. The sources of potential error in this lab came down to errors in time recording, um, because we were doing that by hand. And then the model did not accurately represent the real world scenario. What if we were doing this experiment in real life and used an actual ammeter instead of a simulated one? The difference in real life compared to the simulation is that a real ammeter will have a non-zero resistance that is not accounted for in the simulation. And then what if we were doing this experiment in real life and used a real battery to charge the capacitor with no resistor in circuit? Um, so our ideal model would predict a charging time of 0. Um, but in real life, the wires will have internal resistance, so our charging time would end up being a non-zero value. And yeah, thank you.